Hey friends, welcome. My name is Aryan. The topic of my project is matrices and digital images. So let's start. Digital images can be represented using matrices. The digital image is made up of a bunch of pixels each of a single color. Those colors can be represented by some numerical value. A simple black and white pictures matrix can be represented by replacing black pixel with 0 and white pixel by 1. Digital images using only two colors are called binary images or Boolean images. We can also represent grayscale images by matrices. Each element of the matrix determines the intensity of the corresponding pixel. The next one is RGB color model. RGB stands for red, green and blue. These three are primitive colors. Color images, in turn, can be represented by three matrices. Each matrix specifies the amount of red, green and blue that makes up the image. After representing image by matrices, we can do some operations on their elements that affect the corresponding image. For example, if we consider the binary image A, below is a n cross n matrix, say A is equals to A of ij, then the image B corresponds to the matrix of A, that is B equals to B of ij, that is equals to A of ji. As shown in pictures, figure A is original image and figure B corresponds to A transpose, which is rotated by 90 degree. Figure C is the mirror image of our original image. Now, we will consider one of the method a singular value decomposition, SVD, that consists of writing a matrix A of M cross N as the product of three matrices. Matrix A M cross M is equals to U M cross M into S M cross N into V transpose N cross N. Where U and V is orthogonal, S is diagonal. Here is some examples of matrix decomposition. Now suppose, U1, U2, up to UM are the columns of the matrix U and V1. V2, up to Vn are the columns of the matrix V, then matrix A is equals to USV transpose that is equals to S11, U1, V1 transpose plus S22, U2, V2 transpose up to SKK, UK, VK transpose. If the satellite want to send an image size of 1000 cross 1000, then the satellite would have to send 1 million numbers. As typically only the first elements SII of the matrix S of the SVD decomposition for A are significant, the others are small, it is enough, then, that the satellite sends, say, the 21st columns of U and V, and the 21st numbers SII. That will give an approximation of the original image. For different value of K, these matrices generate approximations to the original image, as illustrated in the following figure. Now we will consider some of the techniques that removes noise from the image. First one is average filter. The average filter works by moving through the image pixel by pixel, replacing each value with the average value of neighboring pixels, including itself. Average, or mean, filtering is a method of smoothing images by reducing the amount of intensity variation between neighboring pixels. Second method is median filter. For each element of the matrix that represents the image, we observe its neighboring elements and, then, we arrange them in an ordered list. The median filter consists of choosing the central element of this list and replace the element at the center by this one. As shown in figure 200 is replaced by median value 82. There are many other techniques in image processing with different objectives. The following images illustrate examples of Gaussian blur kernel, sharpen kernel, edge detection kernel. Gaussian blur blurs the image, but it assigns more weight to middle square so dark pixels stay fairly dark. A 3x3 matrix shown in figure is Gaussian blur kernel. The sum of all elements of the Gaussian blur kernel is equals to 1. Sharpen kernel is shown in figure. The next one is edge detection kernel. Edge detection kernels search for sharp changes in color. Here in edge detection kernel all the numbers in this kernel sum to 0, so if we put it over a section of an image where all colors are roughly the same, multiplying by kernel numbers then adding the results would yield 0 or black pixel, which is why that corresponding area is black. The only area that aren't are, where we find sharp changes in color, means an edge. That's all for this video. Thank you very much.